So the first item for our vocab is a statement. Okay, and for our definitions in this class, you need to start writing. A statement is something, and we'll define what something is in a little bit, that is either true or false. So when we use the word statement in this class, the statement part is something that is either true or false. A conditional statement is a statement in the form of if blank, comma, then blank. And this is one in this math class we will start doing grammar. You must have a comma before the word then. You must put a period at the end of the sentence. These two blanks, if you look in the book, it says that a conditional statement is a statement that has two parts. Those two parts are the two blanks I have. The first part is called the hypothesis. And the second part is called the conclusion. A lot of times in math, we will write things in shorthand. So a lot of times in books, you will see that they will call the hypothesis the letter P, and they will call the conclusion letter Q. And if I wanted to write this if-then statement, if hypothesis, then conclusion in shorthand, I would write it like this. And the way that you read this conditional statement is as follows. P implies Q. Basically what it's saying is that if P is true, then Q has to be true. Okay? Use the shorthand because it's a lot easier to write the shorthand and then interpret the shorthand based off of your individual statements. The next term I want to define is negation. What do you think negation means? Okay, that's one term. What's another way to think about like a -3? It's the blank of 3. It's what? Opposite. So the negation of something is the opposite of a statement. For example, the negation of P would be not P. Okay, we use the word not. Okay, in mathematical symbols, you will either see one of three things. You're either going to see a square bracket looking thing like that, or you can see an exclamation point, or sometimes in some books you will see a tilde. Those three things, depending upon which book you're using, represents the word not. After we get through the definitions, we will work through writing negations of statements. Any questions on our first three definitions so far? We only negate statements. We do, which are individual pieces. We do not negate an entire conditional statement. We do other things with the entire conditional statement. And that's the next ones we're going to go over. So, the next one is an inverse. To write an inverse statement, you negate both the hypothesis and conclusion. In mathematical symbols, I negate the hypothesis and I negate the conclusion. Reason why I write it in mathematical symbols, it's a lot shorter and it's a lot easier to remember. This says not P implies not Q. The next one we have is what is called the converse of a conditional statement. A converse, you swap the hypothesis and conclusion. So if I start out with P implies Q, the converse of it would be Q implies P. Again, we'll use some actual word conditional statements to come up with examples of these. The third thing I can do with conditional statements is write what is called the contrapositive. The contrapositive of a conditional statement is you do both the inverse and the converse at the same time. So I'll write it that way first. Both inverse and converse at same time. So in essence, what you are going to do is you are going to swap and negate the hypothesis and conclusion. The way that would be written in math shorthand is I want to swap, so that's that part, and then I'm going to negate both of these. So I'd write not Q implies not P. I'm going to write an if-then statement, which is called a conditional statement, and then we are going to analyze what the P part is, what the Q part is, and then we're going to write the inverse, the converse, and contrapositive of that statement. One thing that I want you to understand is that even if the truth value of the inverse, converse, and contrapositives would be false, you still need to be able to write the inverse, converse, and contrapositives. Okay? Inverses are still valid even if their truth value is false. That's something that people don't understand. Arguments are either valid or invalid. A valid argument is something that is in proper argumentative form, which inverses are proper argumentative forms, converses and contrapositives are. Whether they're true or false is something totally else entirely. Okay? So I can have something that's false, but it is still a valid argument. And your job in geometry class is to learn how to make valid arguments. For our example, we are going to analyze the following if-then statement. If you live in Port Orford, comma, then you live in Curry County. And we'll just put Oregon in case there's another Port Orford somewhere else. This is a conditional statement. It has two parts. Can somebody raise their hand and tell me what the hypothesis is? Kaya. If you live in Port Orford. So the hypothesis is you live in Port Orford. Somebody else raise their hand and tell me what the conclusion is. Ben, you live in Curry County. So So that's a conditional statement. Is it true? Yes. If you live in Port Orford, Oregon, you do live in Curry County. One way you can analyze this is make yourself like a Venn diagram, where the Venn diagram is just actually the map of Curry County. And where's Port Orford at? It's right here. Is Port Orford inside Curry County? That's what makes it true. So next thing I want to do is I want to write the inverse of this statement. And because I use the mathematical shorthand, the inverse is not P implies not Q. The reason why I wrote the P down and the Q down is now I can directly write my two statements using this. So the inverse would be not P. So if you do not live in Port Orford, then you do not live in Curry County. So let's write that down. Okay, we'll answer that. This is still a valid statement. You need to be writing all of this. If you do not live in Port Orford, comma, then you do not live in Curry County. This is a valid argument. But is it true? No. Can you give me a counterexample? Yes.
If you live in Gold Beach, Oregon, you do live in Curry County.
Okay, so a counterexample is something that proves this false. So if you're there, if you do not live in Port Orford, does that person not live in Port Orford? That's correct. He does not live in Port Orford, but he's still in Curry County, which makes this entire statement false. Okay? So don't just think because something's false that you don't write it down. This is still a valid argument. It just happens to have a false for the answer. Remember, a statement is something that's either true or false. This is a valid statement. It just happens to be false. Next one we're going to do is converse. Can somebody please remind me what the shorthand is for the converse?
Converse is, you swap the hypothesis equation, which is Q.
Q implies P. So I'm going to swap this in this. So my statement will become, if you live in Curry County, then you live in Port Orford. If you live in Curry County, comma, then you live in Port Orford. Is this true? No. Because again, you can find a counterexample, and that counterexample would be somebody that lives in Gold Beach. Somebody that lives in Gold Beach lives in Curry County, but they do not live in Port Orford. And our last one that we are going to do is the contrapositive. I'm just going to write the shorthand down, and then I'm going to ask for a volunteer to tell me what they think it's going to be. And I do want you guys to write the entire sentence in your notes. Can somebody please raise their hand and tell me what the mathematical shorthand is for contrapositive? Not Q implies not P. And then a hand to tell me what the sentence is going to be. Ben? Hands crossed, but Ben?
If you do not live in Curry County, you do not live in Port Orford.
Is that going to be true or false? True. It's going to be true. So the way you do it is you find yourself out here. I don't live in Curry County. Do I not live in Port Orford? That would be correct. So that would be a true statement. If you do not live in Curry County, comma, then you do live in Port Orford. And this statement right here, the contrapositive, is why I added Oregons to both of those. So in your notes, you should have an example of a conditional statement. What is the hypothesis part, the conclusion part of the conditional statement, and turning that conditional statement using its inverse and its converse in contrapositive to write 3 other conditional statements.